At the start of this month, Matilde and Sala each had 100 coins. For Matilde, there was a 25% more coins than she had at the start of last month. For Sala, this was 20% fewer coins than he had at the start of the last month. Total number of coins that they had at the start of last month was. So Matilde, we have now 100, but at the start of the month, this 100 represents 25% more. So if they had she whatever had 25% more, so it's x plus 0.25x, and that is 100. So when you do this math, you get 1.25x is 100, so therefore x is 80. So that's what Matilde had before at the start of the month. And the same kind of story, but this one, be careful. This one is 100 now, but at the start of the month, Salah had a larger number because this represents 20% fewer coins than he had. So it would be y minus 0.2y would be 100. And this is 0.8y. And therefore, when you solve this, you get y equals 125. So at the start of the month, he had 125. And what they're asking is the total. So you take this 80 and you take this 125 and you add them and you get 205, and therefore 11. The answer would be E. A rectangle has length 8 and width pi. A semicircle has the same area as the rectangle. What is the radius? Well, let's draw a rectangle. 8 and pi, as we all know, is approximately 3.14. And this area would be 8 times pi, or 8 times 3.14 approximately, because that 3.14 goes on 3.14, 159, ... right? So that's why, that's approximate. And whatever this is, we'll do that later. Actually, you probably just need to keep it like that. I don't think we really need the numerical value. Okay, so then semicircle. So let's draw a semicircle, like approximately like that. The area of a semicircle would be pi r squared divided by 2. And they're saying this area is the same as the rectangle, so this area is 8 pi. And this is the math, I believe, that will allow us to figure out the radius of the semicircle. So the pi's cancel from both sides, as expected they would. There you get r squared is 16, so therefore r is 4. And therefore, number 12, the answer is B. If a times x plus 2 plus b times x plus 2 is 60, a plus b is 12, what is x? A times x plus 2 plus b times x plus 2 is 60. So if I factor the x plus 2, I will get a plus b. And then they told me a plus b is 12, so substitute that in for a plus b. And then divide through by 12, and you get x plus 2 is 5, I believe, if my math is good. And therefore, x would be 3. So number 13, the answer is A. A line with slope 2 and a line with slope negative 4 each have a y-intercept of 6. The distance between the x-intercepts of these lines is y is equal to mx plus b. That's the standard equation of a line. And the first line has a slope of 2, so that means 2x plus b. So we got a first line, and then we'll do the second line later. And then it has a y-intercept of 6. So that means when x is 0, y is 6. So that pretty much means that b is 6. So our equation is y is equal to 2x plus 6 for that first line. And then very similarly, for the second line, again, the slope this time is negative 4. So our equation is minus 4x plus b. Well, we'll make it capital B because it's a different b probably. And then again, a y-intercept of 6. And, interestingly, this b is also 6. So therefore, y is equal to minus 4x plus 6. Okay. Line 1, line 2. Now we have to figure out the x-intercepts. You get the x-intercept when you set y to 0. So set y to 0, 2x plus 6. And then when you solve for this, x will be negative 3. And in this one, when we set y equal to 0 and solve for this, I believe x will be 1.5. And then they're saying what is the distance. So if we have, the x-axis, and then this will say -3, and this is 1.5, the distance from there to there looks to me like 4.5. And 4.5 is also can be written as 9/2, and therefore 14 is E. A sequence has 101 terms, each of which is a positive integer. If a term n is even, the next term is equal to n/2 plus 1. If a term n is odd, the next term is equal to n plus 1 divided by 2. For example, if the first term is 7, then the second term is 4, the third term is 3. The first term is 16. What is the 101st term? So first term is 16. Okay, so let's follow these rules. 16 is even, so if it's even, it becomes n/2 plus 1. So if this is n, n/2 plus 1 would be 16 divided by 2, which is 8, plus 1, which is 9. So this was the first term. So the second term would be 9. Got it? Okay, so now let's figure out the third term. This term 9 is odd. So we're going to have to use this formula. So it'd be 9 plus 1 divided by 2, which I believe is 5. Okay, so obviously, I sincerely hope we're not going to have to go all the way to the 101st term doing this, but I think there's going to be some sort of pattern, and we can just extrapolate that pattern. Okay, let's keep going. So 5 is odd, so we're just going to have to just use these two formulas. So if it's odd, it would be 5 plus 1 divided by 2, so that's going to be a 3. 3, so that the fourth term is a 3. 3 is odd, so again, the fifth term, which is going to be 3 plus 1 divided by 2, which is 2. 2 is even, so now we're going to use this guy. So that's going to be 2/2 plus 1, so that's 1 plus 1, which is 2. Seventh term, oh, okay, we got 2 again, so it's going to be 2/2, which is 1 plus 1, 2. Oh, we're just going to keep getting 2's now. Okay, that's pretty straightforward. So therefore, if you keep going, the 101 term will also be a 2. And therefore, number 15, the answer is B. "25 cards are randomly arranged in a grid, as shown. 5 of these cards have a 0 on one side and 1 on the other side. The remaining 20 cards either have a 0 on both sides or a 1 on both sides. Laurent chooses one row or one column and flips over each of the 5 cards in that row or column, leaving the rest of the cards untouched. After this operation, Laurent determines the ratio of zeros to ones facing upwards. No matter which row or column Laurent chooses, it is not possible for this ratio to be." All right, I think this is going to be one of those time-consuming things. Well, first of all, what is the initial ratio? What are we doing? Zeros to ones, right? Okay, zeros to one, 0 to 1. The initial ratio, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 zeros, and then obviously there'd be 11 ones since the total is 25, right? Yeah. Okay, so we have to figure out which one of these is not possible. Oh boy. Well, let's just see what we can do. I'm going to try to transform that into a 1510. And if I do that, that's 3 to 2. And that's this choice. And I can do that pretty easily by just making one into a 0. Yeah. So if I just take one of those, whichever one it is, and flip it into a 0, then that means there would be 10 ones and 15 zeros, and therefore this is possible because 15 to 10 is 3 to 2. Okay, so that is done. Again, I'm just going to continuously work with that 1411, see if I can modify it into any of these. How about 12? Let's start with the first one, 12, 13. That would mean I'd have to take 2 zeros away. So 2 zeros would have to be changed into ones, and therefore there'd be 2 less zeros, so it'd be 12 to 13. Yeah, so that obviously can happen, so that is possible. Okay, let's what do we want to do next here? Let's go back and read the question here. Laurent chooses one row or one column and flips over each of the 5 cards. Okay, I think I got it. So, still gotta do some. This one has 4 zeros, right? So if we did that one, and you flipped them all over, and the 4 zeros all became 1, which is possible, then this initial ratio of 14 and 11 would become 10 to 15. Is that right? Yeah, and 10 to 15 is 2 to 3. So that is also possible. Okay, I guess we only have to do one more to get the right answer, starting with this initial guy. How about if I take a 1 and turn it to 0, take another 1, turn it to 0? That is definitely possible. And that would basically make me have 2 more zeros, so it would be 16, and 2 less 1s, so 16 and 9. And there you go. E is also possible. So I guess by process of elimination, the only one that's left is C, and therefore that has to be the correct answer to this question, which is 16. The positive divisors of 6 are 1, 2, 3, and 6. The sum of the positive divisors are 1, 1, 8, 4 is. Okay, so we got to first write out all the positive divisors, and you guys can do that. I'm certain you can write out all the positive divisors. And this is a Canadian exam, right? Yeah. So the good news on the Canadian exams is that you can use a calculator, which definitely makes your life, I think, a little bit easier. It does for me. And so these are the divisors, right? And then you just have to add up all these guys. And when you add up all these guys, you get 2, 3, 9, 4. And that's really all there is to this question. So number 17, the answer is A. If x and y are integers with 2x squared plus 8y is 26, a possible value for x minus y is. All right. So we got 2x squared plus 8y is equal to 26. The first thing I'm going to do is divide through by 2, and then that makes it a little bit simpler. Okay, so I think this is just, unless there's some simple way, this is going to be one of those time-consuming things where you just have to sub in values and see what you can get, first of all, for x and y as integers, and then figure out what x minus y will be. Unless there's some trick here, because I don't see a trick. Okay, so for example, if y was 1, I'm just going to start with y. Does it say positive? No, it doesn't say anything about positive or negative, so they could be positive or negative or 0. Let's just start with 1 and work upwards and see what happens. If y is 1, and we're going to sub it into here, you will get x equal to plus or minus 3. And then, of course, you got to figure out x minus y. X minus y is either 2 or negative 4, and that's not one of the answer choices. Let's keep going. If it's 2, it'll be plus or minus root 5, and that's no good because they have to have integers. If it's 3, it's plus or minus root 2, and then 4, it's plus or minus negative root 3, and now we're getting into imaginary numbers, so obviously pointless to go any higher than 4 for y. So let's go to the other direction, starting with 0 and going to the negatives. If it's 0, it's plus or minus root 13. If it's negative 1, it's plus or minus root 17. Negative 2 is plus or minus root 21. So none of these are integers. This is the only one so far that's integers, I believe. Minus 3, okay, you got plus or minus 5, and then this would be 8 and negative 2. Unfortunately, none of those are the answers. Keep going. I'm going to actually jump over because the pattern seems like you will only get an integer if you, let me think about this. In order for this to be an integer, I think I have to jump to minus 9. I'm just doing it quickly in my head because I just don't want to go through all of them. You guys can do that fairly easily. And this will be plus or minus 7. Oh, okay. So this will be 16 and 2. And is that one of the answers? No, it's not. We got to keep going. How about minus 17? That's the next one that gives integer values for x. And this one gives 26 and 8. And there you go. 26 is one of the answer choices. So with a little bit of trial and error, we get B as the correct answer. If n is a positive integer, the symbol n factorial represents the product of the integers from 1 to n. For example, 5 factorial is 1 times 2 times 3 times 4 times 5. Or 5 factorial is 120, which ends in exactly 1, 0. For how many integers m with m between 1 and 30 inclusive is it possible to find a value of n so that n factorial ends with exactly m zeros? All right, so m is between 1 and 30. Okay, so I'm going to write down the numbers 1, 2, 3, 4, 5, and so on, right? So, for example, if you had n equal to, I'll do the examples on the side here. Let's say I chose n equal to 5, right? Well, that means my n factorial is 5 factorial. Now, 5 factorial, they already did, is 120. And that ends in 1, 0. Got it? Now, the only way you're going to get 2 zeros is if you have another 10 in the multiplication somewhere. And you can have a 10 in the multiplication by having either a multiple of 10 or a 2 and a 5. Okay? So, for example, here we got another 10. So if I did 10 factorial, whatever 10 factorial is, I'm pretty sure that's going to end in 2 zeros. Okay? So far, m equals 1 is valid, m equals 2 is valid. You see what I mean? Because that's representing how many zeros. They're saying from 1 to 30, can you find examples of n for which you can have that many zeros? Well, let's see. So, okay, so I did the up to 10. Okay, 11, 12, 13, 14, 15. The only numbers I'm really interested in are multiples of 5 and multiples of 10. Because, see, 15 is 3 times 5, right? So if you have 15 factorial, you're going to have this 2 and this 5 will create a 10, which will create 1, 0. This 10 will create a 0. And then the 5 that comes from the 15, which is 3 times 5, that can combine with a 2 from anywhere. There's 2's everywhere. This is 2 times 2. This is 2 times 6. So 2's, there's abundant 2's. Every even number has a 2. But the 5's are not as common. So that 15 would give me a third 0. So an m equals 3 is possible, where m represents the number of zeros. You see what I'm doing here? I wanted to explain it, otherwise you won't be able to understand it. Okay, so I'm interested only in 5's and 10's. Let's keep going. This one will give me another one. You see what I mean? This will give me another 0. So the m equals 4 is valid. So what I'm going to do is I'm going to put how many zeros I get by the time I get to each of these numbers. Do you understand what I'm doing there? So m equals 4 we got by getting to 20. Okay. Okay, so because I'm only interested in multiples of 5 and 10, I'm only going to write those guys in. So I'm going to write the next one be 25. Now 25 is interesting. This is where the question actually, you really need to pay attention, because 25 is 5 times 5, so you can get 2 5's from the 25. So you get the 5th and 6th 0 from this guy. But you can only go, let me explain. When you get up to 20 factorial, you're going to get a number that has 4 zeros, right? And that's why I put the number 4 there. But once you get to 25, you'll get a number that has 6 zeros. 1, 2, 3, 4, 5, 6. So you never have a number that has 5 zeros. Do you see how it went from 4 to 6? So I think I shouldn't even put that 5 in there. That'll just make it confusing. Now you say, well, why did it go from 4 to 6? Because that 25 gives you 2 5's. And those 2 5's can combine with any 2's from any of the even numbers to give you 2 10's. You got it? That's why you go from 4 to 5. So I'm running out of space here, but we had m equals 1, m equals 2, m equals 3, m equals 4, but you never get an m equals 5. But you do get an m equals 6. See? So of these, not all 30 are possible. We've already found one that's not possible, and that is m equals 5. That will not be possible. So the number, this guy is out, because at most it's 29, but it's probably less than 29. Okay, so let's keep going. Remember, I'm only interested in values, multiples of 5 and multiples of 10. I'm just wondering, how high do I have to go here? Well, let's just keep going here. 45, 50. Okay, so this is a multiple of 10. So this will be 7, meaning the 7th 0, 8th 0, 9th 0, 10th 0. And then the 50. The 50 is 5 times 10, and then that 5 will combine with a 2, so you're going to get 2 zeros from here. So this will bump the tally up to 12. Does that make sense? So there's no 11. So m cannot equal 11. Yeah, as you can see. So I think that's pretty much the approach. Okay, let's keep going here. Let's so we got 55, 60, 65, 70, 75. So this will be 13, 14, 15, 16, 17 zeros. But wait. 75 is actually 5 times 5 times 3. So you're going to get 2 5s there. So that will jump over to 18. Yeah, because you won't get a 17. So m cannot equal 17 either. Yeah. Okay. I'm pretty sure I'm on the right track here. I'm just wondering, how long do I have to keep doing this, I guess. Until I get up to 30. So far I'm up to 18, so I think I'm close. So the next one would be 80, 85, 90, 95, or 100. And let me see here. This will be 19 zeros, 20, 21, 22. But then you have 10 times 10, so that's 2 zeros. So this will jump up to 24. So m cannot be 23. Okay, so we're getting pretty close to the finish line here. So we got 105, 110, 115, 120, and 125. So this will be 25, 26, 27, 28. 125 is 5 times 5 times 5, so you can get 3. So this number will jump from 28 to 31. That's a tricky one. So therefore m cannot be 29, and it cannot be 30. So of the 30 numbers, we cannot have 5, 11, 17, 23, 29, or 30. So you can't have, how many of those? That's 1, 2, 3, 4, 5, 6 of those 30 numbers are not possible. So that means 24 are possible. And therefore, this question, the answer would be 24, which is D.